Lesson: Comparative Analysis of Programming Languages in AI Development. The comparative analysis of programming languages in AI development is pivotal for professionals seeking to enhance their proficiency in AI scripting. Understanding the strengths and limitations of various languages aids in selecting the most appropriate tools for specific AI tasks, ensuring efficiency and effectiveness. Python, R, Java, Julia, and Lisp are among the most prominent languages in AI development, each offering unique capabilities and frameworks that cater to different needs and preferences. Python is arguably the most popular language for AI development, renowned for its simplicity and readability. Its extensive library ecosystem, including TensorFlow, Keras, and PyTorch, facilitates machine learning and deep learning applications. TensorFlow, developed by Google, is a powerful open-source framework that allows developers to create complex neural networks with ease. Its high-level APIs enable rapid prototyping and experimentation, making it a preferred choice for many AI practitioners. PyTorch, on the other hand, is favored for its dynamic computation graph, which provides greater flexibility and ease of debugging during the development process. The versatility of Python in handling data manipulation and analysis further enhances its utility in AI, as seen in libraries like Pandas and NumPy, which streamline data preprocessing and transformation tasks. R is another language widely used in AI, particularly for statistical analysis and data visualization. Its robust package ecosystem, including Caret and Random Forest, supports a wide range of machine learning algorithms. R's ggplot2 library is exemplary in producing high-quality visualizations, aiding in the interpretation and communication of AI models' results. Furthermore, R's integration with Hadoop and Spark facilitates the processing of large datasets, a crucial capability in the era of big data. R's statistical prowess makes it an excellent choice for projects that require rigorous data analysis and interpretation. Java, a long-standing player in the programming world, offers several advantages in AI development, particularly in terms of performance and scalability. The Java-based Deep Learning 4J library provides a scalable and distributed deep learning framework that integrates seamlessly with Hadoop and Spark, enabling the processing of massive datasets across clusters. Java's object-oriented nature and robust memory management capabilities make it suitable for developing complex AI systems that require high reliability and performance. Moreover, Java's wide adoption in enterprise environments ensures that AI solutions can be integrated into existing systems with minimal friction. Julia, a relatively new language in the AI domain, is gaining traction due to its high-performance capabilities. It combines the speed of C with the usability of Python, making it an attractive option for computationally intensive AI tasks. Julia's Flux.jl library provides a flexible and efficient framework for deep learning, supporting state-of-the-art model architectures with minimal overhead. Additionally, Julia's ability to call C and Fortran libraries directly enhances its interoperability with legacy systems, allowing developers to leverage existing codebases while benefiting from Julia's performance advantages. Lisp, one of the oldest programming languages, has a rich history in AI development, particularly in symbolic reasoning and expert systems. Its unique features, such as code as data and dynamic typing, facilitate the creation of flexible and adaptive AI systems. Lisp's macro system allows developers to extend the language's syntax, offering unparalleled customization and expressiveness. Although less commonly used today, Lisp's influence on AI is undeniable, and its paradigms continue to inspire modern language design. Selecting the appropriate programming language for AI development involves considering various factors, such as the nature of the project, the team's expertise, and the desired performance characteristics. For instance, Python's ease of use and extensive library support make it ideal for rapid prototyping and experimentation, while Java's performance and scalability are well suited for large-scale enterprise applications. Julia's high-performance capabilities make it a strong contender for computationally intensive tasks, and R's statistical strengths are invaluable for data-driven projects. In practice, many AI projects benefit from leveraging multiple languages to capitalize on their respective strengths. For example, a project might use Python for data preprocessing and model development, R for statistical analysis, and Java for deploying the solution in a production environment. This multi-language approach allows developers to utilize the best tools for each task, optimizing the overall development process. Real-world case studies further illustrate the practical applications and benefits of these languages in AI development. For instance, Uber's use of Pyro, a probabilistic programming library built on PyTorch, highlights the power of Python in developing complex probabilistic models for real-time ride prediction and pricing. Similarly, the integration of R's statistical capabilities in financial institutions demonstrates its effectiveness in risk assessment and portfolio optimization, where precise data analysis is crucial. Statistics on language popularity and usage trends provide additional insights into the current landscape of AI development. According to the 2020 Stack Overflow Developer Survey, Python emerged as the most popular language for machine learning and data analysis, reflecting its widespread adoption and community support. Java and R also ranked highly, underscoring their continued relevance in AI projects. In conclusion, the comparative analysis of programming languages in AI development reveals a diverse landscape where each language offers unique strengths and capabilities. Python's simplicity and extensive library support make it a dominant force in AI, while R's statistical prowess and Java's performance advantages ensure their continued relevance. Julia's emergence as a high-performance language and Lisp's enduring legacy further enrich the AI development ecosystem. By understanding the nuances of each language and strategically leveraging their respective strengths, professionals can enhance their proficiency in AI scripting and address real-world challenges with greater confidence and effectiveness.